This is hopefully going to be a very quick video on transformations. I'm hoping that I can get done here in 6-7 minutes. So I'm going to talk quickly, but the idea is that every function, right, all these parent functions that we've been learning about can be written in some way, shape, or form like this. Notice that the a and the k are on the outside of the parentheses. They're away from the x, and the h is on the inside with the x. Also notice that the h has a negative in front of it. That's going to tie very strongly into what we do. Okay, the idea is that this k right here is going to, because it's on the outside of the parentheses, it's not necessarily affecting the x, it's going to shift a function up or down. Okay? If k is positive, it shifts it up. So if k is bigger than 0, if it's positive, it shifts the function up. If k is less than 0, if it's negative, it's going to shift the function down. So we're just taking functions and we're moving them around. This is called translation. Okay, it's going to be translating functions. That h is going to move it left and right because it's directly affecting the x. It's inside with the x. It's paired with the x. So h, but h is backward, right? You would normally think if it were going to be positive in here, it's going to move it to the right. But remember, there's a negative sign in front of that h. So if h is a negative number, that is what moves it to the right. If h is a positive number, that's what moves it to the left. All right? And a is going to either stretch, compress, or reflect it over the x-axis. Okay? So if you have a negative in front of the a like this, if you have a negative out there, that's what's going to take a function and flip it completely upside down over the x-axis. If a is some kind of fraction, like 0.25, that's going to compress it. It's going to make it, it's going to take it like this, and it's going to flatten it, and it's going to get wider. If it's some number like, let's say 2.5, 1.5, anything that's just bigger than 1, right? If it's a number like that, then that's going to stretch it. All right, so we've got a negative sign will affect the a by flipping it. Anything that's some kind of decimal, whether it's a negative decimal or a positive decimal, it's going to compress it. If it is a number that's bigger than 1, it could be bigger than negative, so negative 2, negative 3, negative 4, 2, 3, 4, any of those types of numbers, that's going to stretch it. So quickly, let's look at a few examples. So when you see this, hopefully you see that as an h. It's actually been paired with the x. So if this is my original parent function, which is called the inverse parent function, all right, so the name of it, that's inverse. That's the inverse parent function, okay? What's going to happen is it's actually, remember, h has the opposite effect. That looks like it would shift left to. It's actually going to shift right to. So you've got a negative 2 as an h. It's going to shift right to. So the trick for shifting these things is you identify a point that's pretty significant. Right here for this, I'd say 0, 0 is the significant point. All right? So if I take 0, 0 and I shift it right to, there's my new center point from my new graph. And notice that this goes up, but it never crosses the y-axis, and it never crosses the x-axis either. So this is going to look something like something very similar. Can't cross my x-axis. My new y-axis is kind of like this right here. So I can't cross these 2 points. These are going to be some really rough sketches. But what happened is it shifted right to. All right. Now look at this one. That's a k. Notice that it's not with that x squared on the bottom, like this 2 is. It's not with that. It's on the outside by itself. That's going to shift it down 5. So again, here's my significant point right here at 0, 0 for this function. I'm going to shift that point down 5. 1, 2, 3, 4, 5. Right there. Now it's the exact same point. Notice this never crossed the x-axis, so that's never going to, this new function is never going to cross negative 5. It's going to look something like this. Okay, there's my new function. It's just down 5. That's called the inverse squared function. All right, inverse squared function, inverse squared, and it went down, shifted down 5. Let's see if I can get a few more in here. I'm just going to go through and talk about them now for a second. Here's the logarithmic function. Significant point to move would be probably 1, 0. Okay, and it's going to shift left 3 because that's an h value. So h value left 3, there's my new function. Something like that. Very rough sketch. This one, that's an h value. It's with the x. It's up here in the exponent. So significant point on this one would probably be 0, 1. 0, 1. So I want to shift that. It's going to go right 2. So there's my new point. That's an h value also. That's a k. Notice it's not in parentheses with the x, so that's going to move it down 2. That's another k. Notice it's not in parentheses with the x. It's not paired with the x. You don't necessarily need parentheses. So for example, if I wrote this function like this, x minus 2, and the minus 2 is up here with the x, that's an h value. Now if I put a plus 3 down here, that's a k value. All right, so this is a k value. There's nothing up here with the x. This is another k value. That means it's going to shift down 3. Here's a negative a value. Let me show you what that looks like. It's going to flip this whole thing upside down. So instead of it coming up from the right and then down like that, it's going to actually come from the left. It's going to flip the whole thing. Notice that it's the complete opposite. Just flipped over the x-axis. Everything flipped over the x-axis. And let's see. H value, that's going to go right 2. It's going to shift this whole function right 2. This is compressing. Okay, so this is just going to be a complete estimation, but it should get wider when you see a fraction like that. So let's bring it from out here. Again, that's just a complete estimation because I'm pressed on time right now. So it should get wider than the original function. This is an example of something being stretched. While it's part of a fraction, this is the same thing as 2 times 1 over x. All right, so I'm multiplying by a number 2, which is not a fraction. It's actually getting stretched, so it's going to be a lot narrower. And guys, that is all I've got for this video right now. I don't think there's too much more actually, but if you need just and that was a terrible drawing, but if you need some more help on this, then come see me in my tutoring hours and I will definitely help you out. It's something that's super important. You're going to be using it the rest of this year. So make sure you come and ask. Thanks for watching.